Good morning, everybody. So we're going to start chapter 10, our studies for chapter 10, and our first lesson is on lines, rays, and angles. We are on page 399 of your textbooks. And our essential question for this lesson is, how can you identify and draw points, lines, line segments, rays, and angles? Now, as we start our discussion of geometry terms, geometry is a large part of it is a large amount of definitions. So what I would recommend is that as we discuss new terms, that you create flashcards or some type of glossary of terms. So today, we're just on this page, we're talking about 4 new terms. These are terms that you need to be able to be comfortable with and be able to use at all times as you're looking at the different geometric shapes and angles. So, unlock the problem. Everyday things can model geometric figures. For example, the period at the end of this sentence models a point. A solid painted stripe in the middle of a straight road models a line. So geometry is all around us. Term and definition. A point is an exact location in space. An exact location in space. Think of it as on a number line. When we have a specific spot on the number line, that would be a point or an exact location in space. How do we read this? So to draw it, we put a letter and then the dot for the point. And we read this as point A. How do you rewrite it in words? Point A. An example would be the dot that you draw with a pencil. A line is a straight path of points that continues without end in both directions. So the arrows on a line or on a ray indicate that the line continues in that direction without end. How do we name it? There's going to be this one has 2 points identified on the line, and so we call this line BC or line CB. You can name it with either point on the line. All right, and how would we write it as a symbol? We put the line symbol above it, and then depending on how you're reading it, this one they're naming the B first and the C second, so line BC. Here it's the same line, but they started with naming it with the C first, so line CB. It's the same line though. A line segment is a part of a line between 2 endpoints. Part of a line. A line can't be part of a line segment. A line goes on continuously in both directions. A line segment has 2 specific endpoints. So in this case, you notice that it doesn't have arrows. Okay, so we know that this segment ends. And so we read this as line segment DE or line segment ED. The symbol for a line segment is a line without arrows, and then the name of the points. In which direction are you reading the line segment? Okay. So again, you can choose either endpoint to be read first. Array. Array is part of a line that has one endpoint and continues without end in one direction. So this ray is going this direction. Okay. So when we read array, you have to start with the endpoint. Okay, because the second part tells you the direction. So ray FG, and we would represent it with the ray symbol and then FG. Start with the endpoint. Okay, so those are 4 basic terms. So draw and label line segment JK. So we have line segment JK. That's what that symbol means. And so you can, it doesn't matter how it's oriented in space, just that it has, okay. And let's go back to line segment, and we notice that it has 2 specific endpoints. And it's J, K. Okay. Now, is there another way to name line segment JK? Yes. It could be named line segment KJ. Because you can name it with either endpoint first. You can choose either endpoint. To name first. Okay. So the 2 names for this line segment is line segment JK or line segment KJ. All right. Page 400. All right, so an angle. An angle is formed by 2 rays or line segments that have the same endpoint. The shared endpoint is called the vertex. Okay, so if I just had QP, that would be a ray, right? Because it has a definite endpoint, Q, and it goes on forever in this direction, continuously in this direction. So QP are 2 identified points on that ray. If I only had QR, that would also be a ray. Okay, I have an arrow only on one end, it has a definite endpoint of Q, and it goes on continuously in this direction. They are sharing the same endpoint Q. Okay, this shared endpoint is called the vertex. So there's 3 different ways we can name this angle. I can name this angle PQR. So the vertex is always in the middle when we name the angles, PQR. Or I can go the other direction, go RQP. Or I could just say this is angle Q. How do we represent that? The angle symbol, PQR, angle symbol, RQP, or angle symbol, Q. And so this would be an example of the ray. So this pizza piece has 3 different angles, right? All right, so you can name an angle by the vertex. When you name an angle using 3 points, the vertex is always in the middle. Okay, so again, we call this angle PQR. The Q is in the middle because it's the vertex. So I was using 3 points, so I would name it angle PQR with the Q in the middle, or RQP. And then if I only use one point, I would just say, I would name it by its vertex, angle Q. Okay, angles are classified by the size of the opening between the rays. And we talked about this last year in third grade, and we used the terms right angle, less than a right angle, and greater than a right angle. So this year we're going to apply specific terms to those angles. So we're still going to use the right angle, and we know that that forms a square corner. An acute angle would be the angle that's less than a right angle. An obtuse angle is greater than a right angle, but less than a straight angle. A straight angle is straight. Okay. So how can we classify these angles? Or what tool can I use to classify these angles? Well, if you get a piece of paper, I can show you how to make a simple tool to help measure the angles. So take your piece of paper and put it with the holes away from you and fold it exactly in half, making sure the edges match up. Okay. All right. So we have that. Okay. Now take the part with the holes above away from you and fold it down one more time, making sure that it matches exactly. Okay. So we have this little folded piece of paper. Okay. And we're going to use the corner of our fold to identify the different angles. So right now, the corner of our paper is a right angle. Okay. So if when we put the corner of the paper in the vertex of the angle, if it matches exactly the corner of my paper, that's going to be a right angle. If I can't see one part of the angle, that's got to be less than a right angle because it's not open as wide as a right angle. And if when I put the corner of the paper in the vertex, I see both the lines and it doesn't match the exact shape of my paper, that's an obtuse angle. It's open wider than a right angle. So here's the first example. Put the corner of the paper at the vertex along the straight edge of the angle, or the ray of that angle. Okay. And then you notice that this part here does not line up here. If I was to draw the right angle, so that would make that a right angle. This is open wider. This part here is wider than the right angle. So we're going to call that an obtuse angle. Okay, now B. Okay, I wouldn't put the corner of the paper like that because I'm not measuring anything. So I want to put the corner of the paper matching one of the rays. Okay, just like that. And again, if I drew the right angle, okay, this would be a right angle. It matched the size of my paper. This is not open as wide as a right angle. So this is an acute angle. Okay, so C, find the corner, match up the edge of your paper with the ray, with one of the rays. You can go either way. Okay, I could choose this ray. Okay, it doesn't matter. All right, and then if again I was to draw the rest of the right angle, it would be right there. I can't see this other ray, so it has to be less than a right angle. It's close to a right angle, but it's still less. So this is an acute angle. And D. Okay, well, on that one, I see that it's exactly the same shape as the corner of my paper. This is a right angle. Okay, so you can make a quick tool to help you measure. You will get to the point where you can kind of visualize that, well, that's like this one here. Oh, that's definitely an acute angle. All right. Sometimes we compare it to like the capital letter L in English. Um, if we were to make this L, okay, kind of makes a square corner. All right. Right angles, often you'll see them represented with the little blue square, okay, because they make a square corner. What are some examples of some right angles? Well, where two walls meet in your house are typically right angles. The corner of a door is a right angle. So the corner of your laptop, those are right angles. The corner of a book page, right angles, so on. Those are all things to kind of keep in mind when you're comparing. All right, so let's go to page 401. Draw and label line segment AB in the space at the right. Okay, so when I said that large part of geometry is just identifying or recognizing the definitions, this is a perfect example. If I didn't know what this symbol is, then I can't name it. I can't draw it. I might draw it incorrectly. This is not a line, it's a line segment. So what's the difference between line segment and line? Well, a line segment does not have arrows. It has specific endpoints. So let's draw and label line segment AB at the right. Okay. All right, so choose a space to the right. That's what the line segment would look like. And what is this? It's a line segment. Draw and label an example with a figure. So I see that it has arrows on both ends, and so that's a line. So they want me to draw line XY. There's line XY. It doesn't matter how you draw it, it's just, as far as space, I could go straight across the page, I could go straight up, go at an angle. All right, draw obtuse angle K. Well, if I was using my tool, I could draw bottom part of the angle with this ray, okay? And it's an obtuse angle, so that means it opens wider than my piece of paper, my corner of my piece of paper. So that would be an obtuse angle, and it's called angle K. So we can just put the K right there. All right, draw right angle CDE. Okay, well, this time it matches the corner exactly of your tool. So it's going to make a square corner. And it's right angle CDE. So the D has to go in the middle. Where we put the C and E really doesn't matter on the right angle because that's just how we would read it. So if I put the C here, I would read it still as angle CDE. So angle CDE, right angle CDE. Use figure M for numbers 5 and 6. So here's figure M, and we have to name a line segment. Well, what are some possibilities? TU is a line segment. TV is a line segment. VW is a line segment. So any one of those are possible line segments. TV or TU or UW or VW. So any of those. Okay. It has 4 sides, so it has 4 line segments. Name a right angle. Well, this one is obvious because they've given me the blue corner, blue square, I'm sorry. So I could say angle TUW is angle T a right angle? Well, let's see. If we put that lined up with our paper, I see both edges. So, or angle T, angle UTV is also a right angle. Okay. Draw and label an example of the figure. So this symbol is a ray. So ray PQ. A ray has a specific endpoint and goes on in one direction continuously. The first letter tells me the endpoint, P, Q. Now we have to draw an acute angle with the letters or the points R, S, T. So a right angle, so an acute angle has to be open less than a right angle. So it would has to come in less than a right angle. And the S is in the middle. The R can go there, and the T can go there. Angle RST is acute. Draw a straight angle WXZ. Well, so a straight angle is a line. The middle point of the straight angle is X. And then we just put in the other points, WXZ. For use figure F for line numbers 10 through 15. All right, so we have this shape over here, this figure, and we have to find a ray on this page. Well, there's lots of possibilities. Okay, like right here, I see 3 rays I could use. I could say BJ, BA, BK. I could say RP, RC, RQ. I could say RA, RC. So just choose a ray. Put the symbol for the ray, and I'm going to use BK. It doesn't matter. There's several rays there. Name a number 11. Name an obtuse angle. So we want something that's open wider than a right angle. Well, I'm thinking this line right here is an obtuse angle. So if I put the corner of the paper there, you notice that this line does not match up with the other corner of my right angle. So this is open wider. So I'm going to say angle ABK is an obtuse angle. RBJ is another one. Name a line. Okay, a line has 2 arrows. Okay, so I'm going to say line JK. The symbol for the line is the double arrow line and JK. So anything with 2 arrows would be a line. Line AC, line PQ. So we have 3 lines there basically, right? Name a line segment. So it has to have 2 endpoints. A line segment is part of a line. So I could say line segment BR. Here, that would be a line segment. BR is part of the line AC. Sorry. If I look at line AC, a line segment in the line AC is B and R. Name a right angle. Okay, again, if you have a square corner that's symbolized with the blue square, that's a right angle. So I'm going to name it angle PRC. Name an acute angle. Well, if I put the corner of the paper here at AB, you notice I cannot see the other line. It's closed less than the right angle. So ABJ is an acute angle. All right, awesome. Page 402. Use the picture of the bridge for 16 and 17. All right. And it says classify angle A. Angle A. Well, if I put my corner of my paper there, it matches exactly the corner of my paper. So that is a right angle. Which angle appears to be obtuse? So which one appears to be wider than a right angle? Well, you see how close these two lines are? That's an acute angle. So that only leaves me one other choice. So angle C. How many different angles are in figure X? List them. Figure X. Okay, so let's look B. So we have, I'm going to write them out. DBA. I have DBE. I have FBE. I have angle FBC. I have straight angle ABC. Okay. What other angles are there? So now, so I don't have angle ABF, right? ABF, ABF, ABE, ABD. We do have that, ABD. I have called it DBA. Okay, how about CBF? CBF. Okay, we have FBC. How about CBE? CBE. Nope. So angle CBE. CBD would be another one. CBD. So I've got 9 right now. TBF. TBF. Okay, and we also need this angle here, TBF. Okay, I think that's all of them. So I came up with 2, 4, 6, 8, 10 angles. All right, so they are angle DBA, angle DBE, angle FBE, angle FBC, angle ABC, angle ABF, angle ABE, angle CB, angle CDB, and angle DBF. Sometimes it's easier um, to find all the different angles by using different color pencils. So, like, I could color this angle that color, and then I could color ABF like that, and DB like that. So it it takes practice to identify the different angles. Okay, it can be a challenge. So just try to break them apart the best you can to be able to visualize it. 19. Vanessa drew the angle at the right and named it angle TRS. Explain why Vanessa's name for the angle is incorrect. Write a correct name for the angle. Okay, one more note on 18 first. Because I call this angle DBA, that doesn't mean it's wrong if you said angle ABD. Okay, you'll notice I don't have an angle ABD, but this is angle ABD. So how I named them is just one possibility. Okay, so remember that each angle can be read technically 3 different ways. Now, 19. She drew this angle at the right and named it angle TRS. Why is that name incorrect? The vertex has to be in the middle. So it should be RST or angle TSR or angle S. Okay, R is not in the middle. Okay, you can't put R in the middle of the angle. Write the word that describes the part of figure A. Okay, so just looking at the symbols tells me the answers, basically. So this symbol is a line segment. This symbol is a line. This symbol is a ray. Why did I skip the 2 angles? Well, because it could be acute or a right. So now I have to look. Angle F, angle FBG, FBG. Okay, well, what do I see at the corner of B? I see the blue square, so that makes that a right angle. So this is a right angle. And angle AGD. AGD. Well, I only have one choice left, but let's confirm it. This should be an acute angle. If I line up the corner, you notice that we do not see the other ray. So, acute angle. Okay. All right, so that's our initial discussion of geometric terms. So you need to practice the following terms: obtuse angle, an acute angle, straight angle, right angle. So those 4 different types of angles. Angle in general, so that's your 5th term. And then we also need to know a ray, a line segment, a line, and a point. So we have 9 different terms that you really need to practice and know. So I make, again, like I said, flashcards, and have somebody quiz me and practice. You're going to continue to use these terms. Okay, so geometry really does build on each lesson's previous terms. Okay, so until our next lesson, we will be talking about classifying triangles by angles in our next lesson. So until then, may the numbers always be in your favor.